Okay, guys, I'm just about ready to go here. I'm just finishing up. Can you hear me? Put your thumb up if you can, please. Stephen can hear me. Oh, look, my sheep came up. I'm just a sheep. Can you hear me, Annika? Annika? I don't know if Annika can hear me or not. I texted her and she's not answering. So I'm not sure if my audio is working. I'm just going to go offline for a second and do an audio check. I'll be right back. Okay, well, we'll get underway. I'm not sure what happened. Oh, okay. Annika finally got back to me. She can hear me. That's awesome. So we're just going to have a little review to start with. I'm going to go over transformation so far. So we've learned translations and reflections, apparently, but I should say reflections, in our last two sessions. So we're going to review just for a second what those are, because I don't want people to get confused with the different kinds of things they are. So I'm going to try and find the pages. Excellent. So here we have a Greek letter. And you can see I'm going to copy that and I'm going to paste it. And you can see that I can get a copy of that and I can move it along. So what is the translation that I just did with this shape? Can anybody tell me? What is the translation I'm going to do with this? Just a second, I better move that one so that the M. So the whole thing doesn't fit properly in the box, but let's just see if we can figure it out. All right, so the first thing we're going to do is we're going to take the bottom of this shape and we're going to go down 1, 2, 3. So the first part of our translation is going to be that we went down 3. I'm going to just put a text box up. Well, on the side I thought I was, anyhow. Let's make sure it's big enough to read. Okay, so our first thing is that we went down 3 spaces. What did we do next? So we're at this point here, and I can use my pointer to show you where we got to. I'll get Mr. Sun, he's happy. So we're down to here at this point, right to that place on the paper. Now we know that we have to go either left or right to get to where the shape is now. Are we going left or right? So think which way we're going. We're going that way. Is that left or right? Annika says left, so does Stephen. All right, we went down 3 spaces. How many spaces are we going left? 1, 2, 3. So the next thing we know is that for this translation, and today we had some stuff in one of the, I'm going to make that 24, good. And then we went left 3 spaces. Now today we had one question. It was very interesting because it said there were 2 translations to move a shape from place 1, where it was A, I think, and then it was to A prime. And people missed that there were 2 transformations. This is only one, all right? So that was, in this case, what we have seen is this is a translation. And what we do with the translation is we slide our figures, all right? So our figure slides on the grid, on the graph, to another place. And we should be able to take any piece of that graph and move it, any of the points on the graph, and move them so that we can exactly replicate the same shape farther down. Now we've got an M, but we could use different shapes. So any questions about that one? That's a review on what a translation is. Okay, and this is, a couple kids said this afternoon they wanted to make sure that they understood the difference in different ones. All right, so the next one that we're going to do, and you can see the handy dandy graph paper there, straight line, this goes pretty quickly. The next thing we're going to do is we are going to do a reflection. Now I'm hoping, against hope I think, that we'll find something that we can flip over. So here we go. Oh, that one too. Well, I thought I was doing the miraculous, but apparently not. I'm going to do something. There we go. Close that up. Oh. I guess when I close it, it makes it go away. Here we go. All right. So I'm going to reflect this across the x-axis. I'm going to move it first. And then I'm going to reflect it across the x-axis. So hoping this will let me. So if I reflect this across the x-axis, I'm just going to make sure that it fits right there. And then I'm going to make it come out a little bit more. Come on. There we go. It takes up most of the space. Excellent. So the first part of this, the top part of our, or the bottom part, is our square. So we are going to draw a square, and we are going to go on this side. Now what it's going to do is going to turn it right upside down. So we're going to try and replicate this as best we can. Not sure why I didn't draw the whole box in, but let's just try this one then. They can't confound us. We're getting better with these things all the time. All right. Let's make it orange so we can see that it's orange. There we go. And we're going to draw our square here. Now why am I putting that right there? Why am I putting it at the bottom of the box right there? Anyone want to tell me? It's got to come in a little bit. Okay. Why am I putting it at the bottom of the box rather than the top? No thoughts on that? Because, oh, Stephen's got a thought. Now that's actually a little bit big, I must say, because I'm going to have to get rid of that. Oh, we'll move it in a little bit. Because the other one doesn't quite fit in the whole box, so I think we'll do about there. There we go. That's pretty close. Why is that there? Because it's opposite. That's exactly right. Now I'm going to draw another shape, and this time it's going to be harder for me to do, but I'm going to see what I can do with it. I've still got my orange going. I'm going to start right at the top of the next one, and my shape is going to fill up basically most of this. Now it's going to come in a little bit, so I'm going to do that with my line drawing tool because I can't do it any other way. Where it's just going to come in a little bit. So what I've essentially done is I've turned my exclamation mark upside down. You can see if I cut out those pieces on the other side of it, what you would have is the same thing upside down. So what we're doing when we're doing, this is called a reflection. So we think about that like looking in the mirror. This is a reflection, and it's not a great one, but I think you get the idea. The image is a mirror image. So this is different than a translation because even though it's at a different place on the page, it's also not exactly the same. All right. So now I want to go on, and I want us to go back and look at slide 3. Here we go. We're going to learn in the next class how to rotate an image using a protractor. That's a really specific thing. It's covered in your textbook, and for some of you that think that you might need a little bit of an extra review, you might want to look at that before you come to class next day. But we are going to absolutely learn how to use a protractor to rotate a shape. How is this different in a way than a translation? How is this different than a translation, what you're seeing? Stephen has a notion. And I want you to think about it. I drew a line down the center so you could see. All right. So instead of, it looks almost like this is a reflection. But what I've done here is I've taken this shape, and I'm going to see if I can get a crooked line. what I've done is I've taken this shape and I've taken this and I've rotated it around so that the shape is now upside down. That's right. I'm rotating it on a specific point, and the specific point that I'm rotating it on is right in the center of the heart. So I could have actually put it anywhere else. How many degrees did I rotate this? Stephen's answer, but you guys can't see it. It's a straight line going down. So we know that that's 180 degrees. Let's review our degrees because this is important for this one. So if I get that beautiful corner, if I get the beautiful corner, we know that this is how many degrees? We talked about this earlier in the year. How many degrees is my beautiful corner there? Let's see, it's good. Annika says this is 90 degrees. That's right, it is 90 degrees. Now, it's never going to be perfect on this, but you guys know what I mean. It's 90 degrees and it forms a square. Now, twice 90 degrees is 180 degrees. And that forms a straight line. All right? And then to go around the full circle, we know that is 360 degrees. I don't have a degree symbol for this, it makes me sad. All right? So it's different from a translation in that I could have actually had this heart so that it was facing out this way. So I could have done my heart where the bottom was here, and it could face out this way, and that would have been a 90 degree. This is 180 degrees from the start. Oh dear. 180 degrees. This, if it was facing out this way, would be what? Any thoughts on that? 3/4 of a circle. Add another 90 on. It's going to be 270 degrees. And then if I brought the thing all the way back around to here, that would be 360 degrees. So you can see when we rotate, we take one point and we rotate the whole thing. Now it's easy to see when it's a heart. It's not so easy to see when it's a rectangle. So it's different from a translation in that you're not sliding the shape. You're keeping one thing kind of in the same spot and then rotating everything around it. All right? A rotation moves the shape clockwise or counterclockwise around a point. So how do you think? Take a look at this. This is a 90-degree rotation. So if I rotate the shape 90 degrees, it's easy because all I have to do is make a square where it rotates. This is a 90-degree rotation. And then, I wish I could copy these shapes because they look good, but I can't do it. If I rotated it to here, that would be straight line down, 180 degrees. All right? If I rotated it to here, 270, and if I rotated it all the way back, 360. All right? So that's basically what it's like to rotate a shape. You rotate it around a point, and believe me, you're going to learn lots more about this. So all I want you to do for starters for homework is to use graph paper, and please use graph paper. A lot of you did this right on your Cornell notes last time. It's not going to work so well. So transform a shape, a basic shape, by rotating it 90 degrees clockwise, not clockwise. And you can choose a shape that you can tell has been rotated. So it's really hard to tell if a circle's been rotated or a square. So you'll notice that when I was doing mine, I used a heart, and then I used this crescent shape. All right? That was just to make it easy to see that it had changed. So you don't want something that is symmetrical. All right? Use a ruler to check that you have a 90-degree angle on the rotation. So you know that that would mean, of course, that you would form this perfect square. Okay? And what's going to rotate around that is that one point around the perfect square. All right? And it's easier if you've got a pointy shape, like if I had a pointy shape that went in there, to just, it's really easy to rotate it to there. So like the heart was really easy to use. If I could draw a heart here, oh, that kind of is a straight line, hang on. I'll see if I can draw a heart, you know, about my drawing capabilities, kids. So we'll see. Hey, we're supposed to be a curvy line. Hold on. going to try and draw a heart. Okay, that's the worst heart ever. Just wait. My second half did not work. Okay, try again. That's almost a heart. Okay, so if I was going to rotate that shape, I would keep the bottom part of the heart right to here, and then I would rotate on that, and I would put the heart over the next line. So if you drew a square like that, you could draw your heart right over the next line, and then it would be very easy. And just use your ruler to check that you have a 90-degree angle. I'm going to teach you in class the next day, so everyone needs a protractor, okay? You need a protractor. So once you've got this copied down, you can go. Any questions, you guys? Okay, so if you draw a 90-degree angle and then change the shape over just by, I don't know, using a different color or whatever, you'll see it goes easy. Oh, you have no graph paper. Do you have a computer with a printer? You can go on to Google, and you can actually, in Google Images, find a piece of graph paper. Yes, Mrs. Fair always solves all the problems. So that's for the rest of you too. If you don't have graph paper at home, you can go onto Google Images and print off a piece of graph paper. All right? And a couple of people found at home in their mom's desk some graph paper kind of post-it notes. This doesn't have to be a big graph, so you could do it that way. But that's why I asked you guys to grab a piece of graph paper with your Cornell notes today, because I really want these to be done on graph paper. See you later, Stephen. Thank you. You okay, Annika? You know what to do? Okay, good. Thanks for coming today. Bye. Have a good night.